Hey guys, in the previous video we talked about the bond strength and how the bond strength is connected to the development length, how the development length gives the bond strength. So what is development length? So development length is the length of the rebar that must be embedded into the concrete so that the adequate bond strength between the concrete and the rebar is generated so that the load from one structural member is transferred safely to the other structural member. So that is the definition of the development length. So in this figure, you can see that this over here is our column. So this is our column. This you can see this is our beam. And these lines that you see over here. So these lines, these blue lines, so they are the longitudinal rebars. Okay. And these vertical lines that you see, they are the stirrups. So you can see that the longitudinal rebar comes from here like this. The beam actually terminates over here, but the rebar doesn't terminate. So it goes into the column and after that it goes down. The length from here up to this tip of this rebar, this entire length is known as the LD, that is the development length. So now we know what the development length is. The next thing that we must know is how to calculate the development length. The development length is given by the following formula, and it says that the development length LD must be greater than or equal to, so it shouldn't be less than, but it can be greater than 0.87 Fy times phi divided by 4 times tau Bd, where so we know what 0.87 is. So Fy is equal to yield strength of the rebar. So if you are using Fe 415, then Fy is equal to 415 Newton per mm square. Okay, and phi is equal to diameter of the rebar. Let's say that if the diameter of this rebar is 16 mm, then phi is equal to 16, and tau Bd is equal to bond stress. So what happens is that let's say this is my column, this is my beam, and let's say that this is my rebar over here. So if you apply the tensile force T, then on the surface of this rebar, so rebar looks like, if I just zoom in, so rebar looks like this, and on the surface of this rebar a stress is generated like this. The stress is generated throughout this surface, entire surface, and that stress we call as the bond stress. So this bond stress depends upon the grade of the concrete. So if you are using M20 grade of the concrete, then bond stress is equal to 1.92 Newton per mm square. So if you are using M25, then this bond stress is equal to 2.24 Newton per mm square. And you can get this data from IS 456 code, and if you look at clause CL 26.2.1.1, you will get this data, and this value is for the deformed bars, so the bars that are not plain, the deformed bars. Okay, what this says is that your development length, so whatever the value that you get from here, you put the value of Fy, phi and tau Bd. Let's say that this value is 100 mm. So by putting certain value of Fy and tau Bd and phi, you get this value, and let's say that it is 100 mm. So it says that your development length can be equal to 100 mm, can be greater than 100 mm, but it shouldn't be less than 100 mm. So this is how you calculate the development length. So the development length, if we calculate for certain values, then what we will get, let's say that you are using Fe 415, then in that case you can place Fy is equal to 415 Newton per mm square. And let's say that you are using M20 grade of concrete, in that case tau Bd is equal to 1.2 Newton per mm square. Now put these values in the equation. So LD must be greater than or equal to 0.87 times 415 divided by, so times 5 divided by 4 times 1.2, and this is equal to, this is not 1.2, this is 1.92, and this is also 1.92, and this is equal to, and this is equal to 47 pi. So which means that let us say that if you are using a bar of diameter, let's say you are using 12 mm, then LD must be greater than or equal to 47 times 12, and that is equal to 564 mm. So guys, this is the concept of the development length, and if you see the development length in the real life, then you will see something like this. So you can see that the rebar of the beam goes into the column like this, and this length from the face of the column up to the tip of the rebar, it is known as the development length.